Welcome everybody. This presentation is going to be approximately 45 minutes, which should leave us with 10 to 15 minutes of any questions that you may have as a result of this presentation. So let's go ahead and get started. So to consider the need for a high-end graphics workstation potentially running in the Amazon Web Services public cloud, we need to first kind of sort of dial back for a second and actually ask ourselves where the need is here and what was actually what is being asked for here. I'm based in London, in the United Kingdom, but something that we saw a very large trend for in the graphics and the visual effects studios, and this seemed to be actually more of a global request as we dug deeper and deeper, is the need for potentially workstations that had traditionally always been run on premise. To actually potentially run in a public cloud stack. So it could be the requirement for either platform, Linux or Windows. Traditionally, dual HD or 2K or beyond monitors in terms of the resolution. Color and pixel accuracy, incredibly important in our industry, combined with both audio and video synchronization. And last but by no means least is the ability for even the latest generation of the Wacom tablets and Cintiq digitized monitors to be supported, those including the newer Pro versions, which have actually the 8,000 levels of pressure sensitivity. So the questions actually on why customers may be interested in running their graphics workstation instead of getting all hot and using up lots of electricity under their desk or in their data center, but actually truly remote in a public cloud and not in a kind of a colo data center somewhere. It could be different reasons for different people and different studios. So I feel the story around burst compute has been well told, and the advantages of using the public cloud for large quantities of compute. But the concept of burst artists, the idea that your project is perhaps overrunning, you've taken on more work than your producers previously anticipated, or indeed there's a job that you really don't want to say no to. The idea of bringing in extra contractors, freelancers to increase the throughput and work you're doing, or perhaps specialized artists where the work they're going to deliver for you is perhaps particularly tricky, such as large simulations. So that could potentially deliver the concept of fast pop-up kind of boutique style visual effects studios. It could be the idea that actually you then have much more of a global pipeline, a distributed workforce, where you're essentially going to then have the opportunity to recruit and deploy the most talented artists in the world for a particular project. The idea that it can be secure is a reality here with what we're going to show here. So the streaming pixels is very much motion pictures, MPAA, trusted partner network, kind of deliverable in terms of security compliance. There's no external drives. You can disable the USB flash drives or any kind of external connectivity there, for example, and just have input peripheral devices connecting. And of course, it solves that kind of age-old problem, even with burst compute, if you're in the hybrid model, which is the idea that actually the data synchronization of getting data both to a cloud, remote location essentially, and getting that data, or some of it at least, back to your on-premise location could be solved because the workstation could already be in the cloud and you're just streaming pixels. In places such as London and indeed New York City, electricity could be in short supply, or indeed regular brownouts, blackouts could actually occur, and that could actually be quite an intrusive kind of behaviour when you've got a deadline the next day, for example, with a client. A bit of an Englishman's thing to say here, beat Brexit, but if we just consider the concept of tax credits here, and the idea of them essentially could and do regularly move between different cities and locations around the world, and the idea that actually perhaps moving more and more of my business risk from a sort of a capital expenditure point of view to actually more of an operating expenditure actually then really changes and makes me reevaluate as a business owner the risk that actually then associates with me starting up a new studio office somewhere in the world. The obvious kind of reduction in studio overhead, the physical footprint that the machines actually generate, the electricity, the aircon, and everything else that comes with them. My on-premise location might not even be able to support that, even for a short burst run, where I only need an extra, 50 artists just for the next couple of months. I might not literally have the desk space, and how am I going to solve that problem? And indeed, the promise of the cloud is the idea of higher specification compute instances, which perhaps then lend themselves to be able to solve particular edge problems, such as large simulation data, terabytes of data perhaps that are being generated, but also the ability that perhaps multiple users can hang off in the potential more regular updating of hardware, for example. The refresh cycles could potentially be taken advantage of here. So how does this actually come together? And so this kind of schematic we put together to really demonstrate to everybody exactly what we're talking about that's involved. So the best thing to do is draw a vertical line down the middle, and just to really show the two different use cases here. And so what we're showing along the bottom is our on-premise infrastructure, which has been replaced by any kind of physical infrastructure in terms of the compute and the graphics, in terms of the workstation. And what we have here is from Teradicci, a piece of technology known as the Zero Client, where they use their PC over IP protocol to deliver the streaming capability to connect the monitors, the keyboard and mouse, and perhaps the tablets and digitizing monitors, etc., kind of peripheral devices to an actual physical endpoint, which then can connect to Amazon Web Services via either a secure VPN connection over your public internet connection, or perhaps you'd like to take advantage of dark fiber that doesn't obviously traverse the public internet and so reduces an attack vector through what's known as a direct connect. So that's an actual fiber connection from your on-premise location to one of our direct connectors, it's called Locations, which is the closest one essentially to your office or wherever your point of presence is for your network. And then from there you enter into the AWS fabric, and from there it's fiber dark that we own or lease that goes directly to one of the AWS regions around the world, where it's made up of multiple availability zones, and inside of each availability zone is one or more data centers. So the idea here on premise is you connect all your devices up to this physical Zero client that can be purchased. It's also OEM'd from many different manufacturers. You may already have some in your studio. You can actually repurpose old equipment as well and use the Teradicci software client. But here in this diagram, we're just demonstrating how the Zero client can actually be connected here. Through that connectivity, we then can connect to what's known as the G3 instance type, which is a GPU workstation, and that can be running Windows, it could be running Linux. You could actually use both by having two instances, one running Windows and one running Linux, and turn one off when you don't need it, for example. On the left-hand side, you have a Amazon machine image, or AMI as it's called, and this is essentially your own image that exists in your software installed on it. You can customize it, you can install your plugin scripts, and it can essentially be an exact replica of what your machine instance type, your machine spec might look like in terms of software load on premise. Additional block storage, known as elastic block storage, EBS volumes, can be mounted to that instance, and you can easily clone those instances as well, so you can have multiple volumes of storage mounted to these instances to deliver more and more pure storage, which is Ethernet connected SSD disks to this virtual machine instance that you're running. And conversely, on the right-hand side with Linux, you can do exactly the same thing. Although you may, in the Linux kind of way of working, you may wish to actually have a slightly different setup, where actually perhaps you use a different instance type in addition, such as the i3 which is one of our storage instance types that contains large quantities of NVMe storage, which is local to the actual machine, which then allows you to actually run up an NFS server perhaps on it, and then actually centrally install all of your applications on this instance. And then your G3 custom Amazon machine image virtual machine actually has a relatively small footprint in terms of actual size, a slash boot slash root actual size, because all of the software is symlinked and is actually available and streamed from the i3 instance, which may be an easier way to work from the sort of the Linux point of view, whereas it's preferred on Windows, typically with the operating system, to install the software locally. Now, again, additional volumes can be mounted to give you additional disk space, and they could be RAIDed, for example. And the key thing here is we use the Teradicci software-defined agent known as the Cloud Access Software, or CAS agent for short, which is the software version of traditionally their PCI host workstation card, but it's actually now software-defined. That's running on the actual virtual machine. And this allows the Zero client to connect through the Direct Connect fiber connection or securely over VPN through your public internet remotely to this G3 instance, where it then streams all the pixels to the multiple monitors back to your on-prem location, wherever that may be in the world, and it allows you then to control that instance. And the last thing in this diagram, you can see the Cloud Access Manager, or CAM for short, which is a Teradicci brokering and provisioning tool, which allows you to seamlessly connect the IP address that's delivered locally for the Zero client, and know that essentially that machine should connect for that user to the particular G3 GPU instance in Amazon. If you consider the case of multiple users, you need to make sure that user A connects to user A's workstation, etc. So something to kind of sort of consider, as always, is latency. And what we mean by this is, as well as having a good actual network connection to be able to stream the pixels, what we actually need is a line that has good low packet loss, and latency is obviously as low as possible is always best. Now, before we kind of do a comparison and look between the difference between public and this dark fiber direct connect connection, we just need to consider sort of how this affects, how does this look in the landscape of streaming pixels with Teradicci. So with a latency that is less than 25 milliseconds, typically what you would do is you would use the Cloud Access software version 2.11 or later, and you would carry out the virtual bridging of the USB ports between local and the actual device. This would allow you to then forward the port that the Wacom tablet is connected to, and that actually then allows a very nice, seamless, interactive experience with the Wacom tablet. Now, the better way to go, if possible, is to use the latest and greatest firmware from Teradicci, which is actually in technical preview at the moment, 6.2, which actually locally terminates the Zero client, the Wacom drivers in the Zero client. And so for some of the latest Wacom drivers, the PTH 660, which is the medium, the 860, which is the large, combine that with the Cloud Access software, so version 2.13 or newer, and combine it with a new flash firmware for the Zero client 6.2. It actually then terminates the actual Wacom drivers, just the same as the keyboard and mouse. That's always worked well. And it allows much higher levels of latency to be supported for these tablet devices, and this includes the some of the Cintiq devices. Now, as always, you should use the closest AWS region for pure and simple reasons that I can't, or no one can fix the speed of light. Those rules, or that rule always applies. But the great thing here is you have some options here depending on the latency levels and the way in which you're actually going to connect to AWS to be able to run this. Now, let's actually have a look at those latency levels now. Now we've got all that hopefully into perspective. So these are actually measured latency examples. And the key kind of messaging here is it's obviously never guaranteed because it's always going to be dependent on the last mile to your actual location, to your point of presence, which is something not necessarily in control of. So we need to just take that into account as a disclaimer. But having that said, these are kind of measured latency levels that we've looked at here. And what we've got on the left is typical, not all, of course, because there's many places that visual effects takes place, but some of the most popular cities around the world, the nearest AWS region to those cities, sometimes multiple options, and what the latency would look like if you were connecting to us publicly, and then what that connection in terms of latency would look like if you then had a actual dedicated fiber connection, which is great because it reduces the attack vector. No, it's essentially it's a private dedicated fiber line for your studio. But of course, you could just wrap a VPN on the public internet connection, and that's another way to connect to us. As always, the dedicated fiber link is always going to deliver lower latency levels than the public internet because we're in control of how many hops and where the switch in and everywhere it goes, essentially a lot more. Also, you have no contention whatsoever with a fiber line. So you can see here, given though those numbers are quoted in the previous slide, with the latest kind of firmware and everything and software that's coming from Teradici, and being able to support greater than 20-25 milliseconds. Even the highest number there is actually LA connecting all the way up to Portland, Oregon, for approximately 35 or slightly more milliseconds. You can actually see here that that really is not a problem anymore because we can stream the pixels quite adequately if the Wacom tablet is connected as well. Now, an interesting thing, perhaps I didn't mention it in those slides, was if there isn't a need for a Wacom tablet to be connected at all for a particular artist, because not everybody uses one, then that's not really a problem at all. The keyboard and mouse work incredibly well at much higher latency levels, and that's because they've always been traditionally locally terminated, their drivers in the silicon of the Zero client in Teradici as well, and that's essentially what's now happened with the latest firmware with the Wacom. So just to dive into the G3, as I referred to it, just a quick explanation if you're new to AWS. The EC2 instances and the naming convention is as follows. G for graphics. They're generally all pretty logical in terms of the letters of the alphabet that we use. M for memory, it's our general purpose instance type, for example. And then the number is essentially the generation type. So the G2 was the second generation previous to the G3 now, and G4 would be the next generation. The t-shirt size, or the number and the word that comes after the period, is essentially an increase in number to define the size of the instance that looks like a t-shirt, for example. So small, medium, large, extra large, 2, 4, 8, 16 extra large. So we can see here that with the increase we get not only an increase in CPUs but also a doubling of the RAM and also an increase in the actual number of GPUs. And as a result, that actual instance would then have more CUDA cores, for example. Now, the G3 instance type is based on the Tesla M60 graphics card, which a single one of those delivers 8 GB of memory and the 2048 CUDA cores. And what we're going to do, we're going to put it into a particular kind of mode, which is called the GPU pass-through mode, and that's part of the grid system, which is licensed, and that is included in the price of the G3 when you run it. So there's no additional licensing you have to go and get. That's all done for you and handled. And there's a slide later on just to explain what grid is and how that actually works a little bit deeper. Now, the 4XL is which contains the one graphics card, the M60. The M60 has technically got 2 GPU in the one physical card for those that are interested. So although it's a physical card, it's actually divided into the 2 GPU. So when you actually see the 8XL, for example, on 2 GPU, that's one physical card. So on the 4, it's obviously 2 physical cards, divided both cards to make up 4 GPU. Okay. In terms of the actual Intel processor spec, the 2.3 gigahertz base speed has turbo cores up to 2.7. It's an 18 physical core, and then it turbos to 3 on up to 2 of those cores is the actual Intel CPU spec. And the great thing is that the additional CUDA cards means that this graphics instance type is fantastic for actual headless GPU rendering using some of the most common GPU renderers, V-Ray GPU, Octane from Otoy, and the Redshift GPU render engines are very popular in the industry. But when it comes to actually streaming for the monitor, having more than one GPU is actually a waste of time. Of course, with the exception that if you're then running an application that can use more CUDA cores, perhaps it might be something like the Mercury playback engine in Premiere Pro, for example, then that's CUDA accelerated, in which case having more CUDA cores makes sense. But when it comes to purely streaming the pixels to your monitor so you can see your twin monitors on your desktop, more than one graphics card is irrelevant here. And the grid licensing and the way that this setup can work, we can support actually up to 4 monitors here at that resolution. So if we just narrow that down, then let's just filter that view and just look purely at the bottom spec, which is the 4XL, or is it? I'll come to that point in a minute. So there's different types of pricing, but we'll just consider the on-demand pricing. Now, for those that are new, on-demand pricing in AWS is when essentially it's the standard retail price. It's the price you pay if you come to us with no notice and say, hey, can you give me 10 workstations now, please? And you execute the command, or you open up the AWS console, and in the GUI you launch 10 instances. And if we have them available, we'll give them to you. And if they're being used by someone who's perhaps using our spot market, which is the heavily discounted instance types, those could potentially be terminated, taken away from someone on headless rendering, and then given to you. So it's the on-demand pricing. Now, it's not absolutely guaranteed. That would be the reserved instance, RI for short, pricing model, where those machines are dedicated to you and they are always available to you because they are essentially your machines. So that's the 3 types: reserved instance, on demand, and spot. So what we're looking at here is the no notice, just turn up, press the buttons, and these machines are instantly available to you. Now, if we just consider the pricing model of not 24/7, because we're moving towards an operational expenditure here, and consider that actually you need to turn the machine off. Don't just walk away from it when you go home, but actually if the machine was automatically idle and detected and turned off, and perhaps only runs for 10 hours a day, let's say, and it's only 5 days a week, so not at the weekends and not overnight, without even taking into account that most employees would probably take a couple of weeks, maybe a month if you're lucky, vacation in the year. So you could say out of 12 months, you're only paying 11 months. We haven't taken that into account. So the numbers could be kinder here. But essentially at 247 a month dollars, you could run this instance type, which equates to $1.14 an hour. The Windows cost includes the operating system license cost for Windows, where obviously you won't have that with Linux. Then you have the Teradici cost for their cloud access software, the CAS agent, which runs either as a 50 cents an hour option, or it's a 240 per year, and that's per instance, okay, per machine essentially. And then if you're using the direct connect, then the egress charge, obviously streaming pixels and the amount of data that's streamed is really quite low. There is a charge to make you aware of, but really it's really is quite low because it's per gigabyte and you're streaming literally pixels, so kind of in the megabit range. So I alluded to it when I said the G3 4XL is the smallest instance type. Actually, as of 1 week ago, on the 11th of October, we actually announced this slightly smaller type. And there's a couple of exciting things here. It just has the 1 GPU in it, which is all you need for streaming. It has a reduced number of CPUs and RAM. It's still got over 30 gig of RAM inside of this machine, and it's referred to as the G3S extra large. And you can see here that as a result, the on-demand price, both for Linux and Windows, is dramatically lower than the previous 4XL instance type. And what I thought was kind of interesting is the on-demand pricing. You can see there on the left is how does it actually equate if we were to use these instances, not for workstations, but for actually for GPU headless rendering. And you can see there that if we just want to get as many GPU instances as possible, as cheaply as possible, which would in this case be Linux, instead of the 34 cents, and these are all based on the pricing in our North Virginia, which is our US East one region, which is typically where we always just quote across the board of AWS all our prices, so it's all consistent in one region. You can see here it's gone from 34 cents, you now drop into 22 cents just to get hold of that GPU instance. But what I find quite exciting is the on-demand price has gone from $1.14 to just 75 cents an hour for your workstation. So these prices and this new instance is available across quite a few of our regions, not absolutely every single one, but it's actually listed in the bottom there with North Virginia, Ohio, Oregon, Frankfurt Island, and in Asia Pacific with Sydney and Tokyo regions. And that is a considerable saving based on where the 4XL was before. You still receive the grid licensing and still use that as a workstation. It's still got the one GPU, get the big of the Tesla M60s. There's no reduction in the GPU capabilities there whatsoever. It's a case of reducing the CPU and the RAM to deliver an even more cost-effective instance for you. If that amount of specification in the machine is good for whatever you're trying to do, perhaps you're just a modeler, for example, and you don't need any CUDA capabilities, for example. So in terms of the actual workstation specification here for Linux, just to kind of sort of give you a demonstration of what we've built out internally as our testing tools to show what is capable here. We used a fiber connection, so a direct intended latency as much as possible. We used the 4XL because the smaller instance type wasn't available when we did these tests and this build out quite some time ago now. And we used this particular version of CentOS, which is kind of sort of a mainstay for the visual effects industry. A byproduct of it was that the libraries and kernel and stuff are quite consistent with where the community-led VFX platform is going. And then the particular version of the NVIDIA grid driver that we used is really quite modern, in line with the latest Quadro drivers. And then we grabbed hold of the latest Teradici cloud access software at the time, which is 2.13, and we connected a couple of those Wacom tablets and proved and showed that it works really, really well at that kind of latency level with a 0. The default frame rate now is not 30, it's now 60 frames per second. And Teradici are continuing to iterate and add new features and enhancements to their protocol, which just makes this experience just better and better. And then we grabbed a relatively new, if not latest, Wacom X driver for Linux, 0.40. The key thing really is a minimum of the .35 version, and that's because an environment variable was added, which is called pressure 2K. And if you happen to be using an application that perhaps hasn't been updated yet, which doesn't fully support the 8,000 levels of pressure sensitivity, then you can easily just set this environment variable. This is just for Linux only. That's required. You can add that environment variable, just set that to equals true, and then that locks your tablet down to 2,000, the traditional levels of pressure sensitivity that you would get with a Wacom tablet. And so if you have got an application that's got any problems there, you can easily just solve that. Now, combining all those things delivers a fantastic experience for the user. And what I thought I'd do is just take you through some slides in terms of the actual kind of how some of this technology comes together and where you can find it for some background reading for yourself. So And to understand the different versions, driver versions in the libraries for the NVIDIA driver set, it's important to understand that the grid drivers are very, very similar to the Quadro drivers, but you can't just go and download the latest Quadro driver directly from the NVIDIA site. We actually make our drivers available through an S3 bucket, which you can easily just one command line, one command, and you can just download that. And in terms of the documentation of what those versions and numbers look like, because it can be a little bit confusing, we always provide the latest versions available for you in IS3 bucket. But just to give you an idea that currently, right now, as of today, we're running Grid 6.2. And so you can see there that the Linux driver is 390.75, and you can see that the Windows driver typically is always a different number. It's never going to be identical, different build numbers. So it's 391.81, and those drivers are up to date as of July 2018. Why is this important? Well, because you will find there are discrepancies if you try to use older graphics drivers, older grid drivers. The latest versions of popular digital content creation DCC applications like Maya and 3ds Max or Cinema 4D, for example, might have problems if you're not running a new enough grid driver. So it's always important for us to keep these drivers up to date. And yes, we will be upgrading shortly to Grid 6.3 with the absolute latest. That was only just released very, very recently in October this month, which is when this webinar is obviously being recorded. But if you ever need to make reference to any of this, this web page is available. So I alluded to this as well earlier. So the way in which NVIDIA licensing works when it comes to the grid technology is essentially taken care of for you completely automatically in the layer between the EC2 instance running on our infrastructure that we host and the actual operating system image, the virtual machine that you own that's in your AWS account that runs on top of our infrastructure. So that layer in between is where we actually then coordinate and ensure that a license is delivered to you. Whenever you run a G3, under any circumstances, we deliver that license. But the actual grid licensing is essentially capable of running in one of three modes. And there on Windows, there's a registry key that you can update, and this is all in the AWS online documentation for the G3 instance type, by the way. And on Linux, it's a configuration, a .conf file that you can update, which actually allows you to change the grid licensing version. Now, by default, we actually enable the grid licensing to grab what's known as a Quadro virtual workstation, or DWS, desktop workstation license, which is the last column, the third column on the right there, which essentially gives you a license and the capabilities to do all those things that are listed there. However, if you wanted to change the grid driver, it's completely possible, and you could put it into true grid mode or actual VApp, the virtual application mode, which allows you to run different types of visualization technology. So say, for example, something like VMware Horizon could be run as a different option there. But the key thing is the second to last row where it says GPU pass-through supported, and indeed the CUDA. So with the Quadro desktop workstation mode, DWS, we've got yes to everything. We've got CUDA. We've also got OpenCL, which is super important for like Houdini acceleration. It has some OpenCL, for example. And we also have the full strength of the GPU, so it's complete pass-through mode. So it's literally like you have the graphics card and it's plugged into the PCI slot on an actual physical computer that's under your desk. So something that's I think is always worth mentioning here is the other instance type known as the P3 instance type that we have as part of our accelerated computing platform, which can be used for machine learning activities, for example, and lots of GPU processing. But this is the thing. It's got the Volta V100 Tesla graphics card in it. It has quite a lot of CUDA cores in it, so I thought it was quite good to actually show the representation of the number of CUDA cores from the three different sizes of G3, of which what's not included there is the brand new smaller G3 instance type, but it would be identical because it's one whole GPU, as I said, so it would be the same at 2048. But what's kind of incredible is you can take something like the G3 4XL with the 2000 CUDA cores and have something like the Redshift GPU render engines benchmark, one of their benchmark scene files, which takes approximately 10 minutes to process of that size instance. And if you actually put it on the top of the range 16XL P3 with just under 41,000 CUDA cores, that render time reduces to approximately 15 to 20 seconds. So there's an incredible kind of difference there in terms of what's achievable if you throw the right kind of instance type to solve the problem, which can actually be quite incredible in terms of the number of headless GPU render nodes that you could actually have, how quickly and throughput in terms of the number of iterations for render that you could actually then deliver by using these different types. So in terms of consuming what I've shown today, there's actually quite a few different ways that we've presented this information and we're delivering it to customers. If you're interested in testing out workstations, whether you're Linux or Windows, makes no difference to us. So one of the ways is through our marketplace, which allows you to simply go to that URL with an AWS account. And Teradicci have kindly published on our marketplace 2 pre-built images where you have either CentOS 7 or Windows Server 2016, which would run Windows 10 essentially, desktop experience on those machines. The NVIDIA drivers, the grid drivers are already installed, the latest ones, and the Teradicci software is installed as well, the agent software, and a license is also obtained seamlessly, automatically for you. And when you click on these marketplace offerings, they also will then subscribe, essentially, it goes into your AWS account and into your console. So it goes into your account. It doesn't go into some black box. It's completely under your Steam. You can see this stuff in your account. You can run up that instance, and as well as consuming obviously EC2 instance runtime, which is the operational expenditure, the charge time, i.e. how much we charge per hour for those instance types, but also the Teradicci software is wrapped up and it's all becomes one kind of all-in price for you. And then you just need to add your applications, your software, and your licensing, assuming that the EULAs are all allowing you to install whatever software that you'd like to install on top of this image. Back in July, I actually published a blog post, so you can go to that URL, or simply if you just do an internet search for the title there, building a GPU workstation for Visual FX. If you scroll down that blog post, it is literally a step-by-step guide. It's got shell commands if you're in Linux, it's got PowerShell commands if you're in Windows. Some of it's in the GUI as well for Windows, but it essentially shows you how instead of using the marketplace offering, you can take the base virtual machine image and completely go build this yourself. So if you'd like more of a sort of a DIY experience, but essentially you'd like to see how this all comes together, perhaps you have a requirement to customize it at somewhere between the driver set or at the operating system level. There's a particular version of Windows or Linux, for example, or a different version of Linux that you'd like to use, then this is an option for you. And then we get to the bottom of the blog post and we actually can just log in using the software client, which is a great way to test this stuff out as opposed to having to have a zero client. Teradicci has a software-based client that works on Windows and Mac with a Linux in preview that allows you to log on like a VNC-like experience, but much more powerful. It allows you to connect to your Windows or Linux machine, and there I'm demonstrating 3ds Max and Maya as well. So another way, it just keeps coming. So AWS has the concept of Quickstarts. They come with a nice PDF guide and a landing site, and essentially they are an automatic way of spinning up the infrastructure that I showed you earlier, but set up with some nice extras. So here you actually have Active Directory services already connected within your VPC, which is your virtual private cloud within AWS, with an internet gateway that's load balanced. It's all pre-configured for you, and essentially it's published as what's known as CloudFormation. And CloudFormation in AWS is essentially our way to automate. It's DevOps. It's the way to automate essentially a template or a script that you customize, and what we've written here, which essentially automates the provisioning of all of this. And this is something that carries across the whole of AWS in terms of you can automate absolutely everything. Now, these cloud published on our GitHub site. So the Quickstarts could actually be downloaded by you. You can actually execute the CloudFormation script yourself and customize it even further, change what bits you don't like. Or you can just click on these and just let it run for you. And in under 30 minutes, I think it takes about 20 something minutes, it will deploy this entire infrastructure for you. And it's another way to consume and have this stuff set up for you. There's a deployment guide, as I said, and all the license costs are all outlined there for you as well. So just to finish up, to actually test this, if anyone is interested in perhaps doing an actual proof of concept, a POC project with us and would like to talk further with us, a great way to get hold of the entire Thinkbox team these days is through our contact page. The URL is just up there, but essentially you can just do an internet search for Thinkbox software, and we have a contact us page. And if you just fill in the details and get in touch with us. In terms of the POC, AWS can provide you actually with EC2 usage credits, so you can actually test this stuff out, kick the tires of it, and actually see if it works as well as I'm saying it does in your location with your software, and whether your artists actually like it. We've partnered with Teradici, and they are also sponsoring trial licenses of their software. They provide a 60-day license of cloud access software, and you can simply go to teradici.com and you can request that trial license from them and license the software. As I said, it's also pre-licensed as part of their marketplace offering, so that essentially would automatically happen for you if you go the marketplace route. And then finally, our partners SohoNet, which is a great network provider, very popular in our industry. They're providing for existing SohoNet customers that are on net with SohoNet. They're providing a free trial of their Fastlane product, which actually allows you to connect to AWS through that dark fiber connection, which is actually then managed by on our behalf by SohoNet for you. So you can actually experience what that's like to have a really fast link that's not contended. So it just allows me to say thank you very much. I hope all that was interesting or useful for you.